Brendan, did you do homework? I need to check. I need to check Nicholas and Brendan. I forgot to check the table.
Ella, get off the floor.
Yeah, you did I know. You only go by the papers.
I just didn't know.
You're gonna love it. I'm loading fucking
All right, shh. Listen up, listen up. We're gonna go synthetic division. Synthetic division is a lot easier, but also we can talk about something else as well. So, when can we use synthetic division? The situation are very, very easy. If you ever have, just says, if you have, my screen's not showing. Okay, my bad.
You're also not.
What?
I was joshing. I'm sorry.
You are joshing?
You know who Josh is?
No.
It's okay. I'll play it later.
I know. I learned a new term. Either I can call you a break.
Is it Cyber?
No, I can call you a brick or a burger. Which one you prefer?
I'll be frick.
Yeah, you are.
I'll call you Juan.
A grit? Oh, really?
Or you could say I'm cooked.
No, cook I know. That's so last year.
You know what 6'7" means?
Yes.
What is 6'7"?
It actually means person's height. According to the lyric.
6?
I look it up, trust me.
Did you really? Have I been the most loser thing I've ever said? I look up, what, 6'7".
I'm writing.
These motherfuckers don't tell me shit.
A long time ago, I looked it up. What a trap house thing on the dictionary. All right, so shh. All right, so what we're gonna do is we're gonna take this x cubed plus 4x squared plus 5x plus 5, and we're gonna divide this by x minus 3. Now this is gonna be a lot easier if I use synthetic division. Now you can practice a long division, and I'll teach you how to do synthetic division. So do long division first. See how long it take you, and then we're gonna teach you synthetic division, and let's talk about the situation when you can use synthetic division and why do we need to use it. There are two reasons why you can use synthetic division. One is called remainder theorem. Remainder theorem is actually very useful, and also something called factor theorem. And factor theorem is to help you how to factor something, which is much more powerful than before. So let's do long division here. X cubed plus 4x squared plus 5x plus 5 divided by x minus 3. So we're gonna first try long division, and then we're gonna teach you like what are the things, why those numbers come in play when they're synthetic, and why do we do that. How many of you guys remember synthetic division? Raise your hand if you do. Okay. You can try it without me going over it. Try it first if you remember it. If you don't remember, just wait for me. No? Who's your teacher last year?
She taught it to us, but I preferred long division, so I kind of like erased it from my memory until the last minute when I needed to look at it for the exam again.
It's actually in a way, there was two purpose for standard division, and we're talking about the second purpose, which is remainder theorem, and also three purpose, which is factor theorem. So you can use that a lot better on different situations. So you do need to know standard division for a different reason. Long division is something I prefer also because it has more capability to do different kind of division.
I'm almost done.
Wait, no.
I don't think it's 78. I think it's 53. 53, right?
26 times 3.
Oh, okay. This is a plus one.
Wait, what's the last term you had? Last term you had.
All right. So I'm gonna start with the second term. I'm gonna go with x. I'm gonna go with square. So it'll be x to the third minus 3x squared. And this is a minus sign. I'm gonna go do that minus sign. So this 0, this is gonna be 7x squared plus 5x, and we're gonna say plus 7x. So it's gonna be 7x squared minus 21x, and again this is a minus, so this is gonna be 0. This will become 26x plus 5. Is that okay? And we're gonna plus 26, so it'll be 26x minus 78. So that will end up to be 82. Is that okay? Oh, 83. Sorry, 83. Is that okay? So it'll be 83 x squared plus 7x plus 26 plus 83 over x minus 3. Now, with that being said, hey, there are two purposes for using the division. So when can we use in the division? So here's the rule of.
The teacher said so.
So when a divisor is x plus a c or x minus c, not 2x plus c, not x squared plus c. C is a constant, so it could be 1 or 2 or 3 or 4. So c is just some type of constant. So I'm just write down c is constant. So a number. So x plus a number or x minus a number. Now, could I do it with the 3x minus number? It would work if you know the tricks. But I'd rather avoid those tricks because in that case, I'd rather use a long division. So right now, if it's x minus a number, x plus a number, then you can use standard division. Now, what do you think is going to be first? Is going to change the sign of the divisor and put in a corner. And I'm talking about corners like this. Take a right hand corner like this, and you change the minus 3 to 3 like this. So if it's x minus 3, you put a 3. If it's x plus 3, you're gonna put a negative 3. Is that okay?
What did that say?
Change the sign of the divisor and put in like a right corner like this. And then the second step is write down the coefficients, write down the coefficients of the polynomial. Now make sure I want you to highlight something is including the placeholder. And what I mean by placeholder, if you have a skipping term, you have to put down 0x or 0 something. So in this case, it's going to be 1 because this is 1. Do you see this is 1? I'm going to put down 1. What's the next number?
4.
4. What's the next number?
5.
5 and 5. Remember, sometimes the negative, you're going to put negative. Now, you're going to do drop the first term. with the arrow. What I mean by arrow, because I can occupy that space, I don't use that space. So I drop it, I draw, I become a habit, I draw an arrow from the first term, and I put a 1. The fourth step is going to be multiply and add. Multiply and add. So I'm going to multiply this by this. Instead of subtracting like before, it's going to be adding. So 1 times 3 is what? 3. And add together is going to be what? 7. And you're going to do it again. 21. And this is 26. And then this is going to be what? 78. And this is 83. So, and then all you gotta do is write down the descending order. So this is third degree. So it's going to be 1x to the second degree plus 7x plus 26 plus 83 over x minus 3. So second step says write down the coefficient of the polynomial. So this is the coefficient 1, 4, 4, and 5. And third step says drop the first term with the arrow. I draw arrow there so I don't occupy that space, because sometimes they don't draw the arrow, they occupy that space, and they'll add a number and shift it a little bit, and they end up getting answer wrong. And then multiply and add. So you're gonna drop this number and you're gonna multiply this number, place to the next space, and then just add them together. Okay, there's two purposes of this question though. Let's talk about a two purpose. Yes. You had a question?
We multiply, drop down the one, we multiply by 3, the 3 goes under the 4.
Yep, and then you
Do
add
that
them.
again, 3 times 3. Wait, no.
3 times 4, or 3 plus 4 is 7.
7, and drop it down. So addition and multiplication.
Yeah, adding and multiply.
And then move it down, and then addition, multiplication, and move it down.
Multiply and add, sorry. You multiply first and then add. Multiply first and add. Then you see this is a start with the third degree. Your answer is going to be 1 degree less. 2, 1, 0. What?
Someone is Domino's Pizza.
What do you mean? What'd you get 5? 7 times 3 is 21.
Oh,
No.
5.
Domino's Pizza in the school.
wait, Mr. A, isn't it always 1 degree less?
Yeah, I smell it.
Yeah, your answer should be 1 degree less.
Like always?
Yeah. Because you divided by x, you're reducing by x 1 degree.
I'm gonna bet money on it. Mr. J, I bet money on it. Next room has Domino's Pizza. Or the room, the 2 rooms there. You smell it? I bet money on it. Either that one or Shaw has it. Bet money on it.
I don't think it's those 2 rooms.
I think it's those 2 rooms. On my life, those 2 rooms. You want to check after school? We'll literally go down. I guarantee.
How much money on it?
$20. $20. Those 2 rooms right across. Right here. Either one of those 2.
Which room? You need to be more specific.
I can't guess the exact. No, because I think it's those 2.
Financially responsible.
Yeah.
All
I
right.
would say at least those 2.
All right. All right. Make sure.
$20 on Davies. $10 on Shaw. So if it's either one, I get like whatever.
I'm pretty sure it's not Shaw.
I know,
She's
Shaw-
Indian. I don't think she eats pizza.
Exactly.
Hold on, if you lose, then you have to pay 30.
No. If it's not Shaw, I don't like. If it's Davies, I get.
But
20.
David,
Shaw, then I get
David
20.
has planning. David doesn't have planning, so if you have pizza, then it has to feed 40 kids in the classroom. So no, it's not on both.
No, it's Davies.
Miss Davies
It's
gives
Davies.
the kids donuts.
I bet it's
Huh?
Davies. I
Miss
bet
Davies
it's fucking
gives their
Davies.
kids donuts if they have the best test scores out of all our classes.
Oh, okay. I don't know.
She could easily do the
I
same thing
smell
with
it in the
pizza.
air, bro. I'm so serious.
All right, shh. I need you to do this. Now, make sure you have placeholder. What do I mean by placeholder? If you have a skipping degree, so that's to say, if you have x to the third degree to the x to the first degree, there is a 0 to holding in place for the x to the second degree. Does that make sense?
Yeah, the exponent power needs half inch.
Yeah.
Or it doesn't.
So, I'm going to give you this one, so be careful. 5x to the cube plus 6x plus 8 and the x plus 2. I'm going to take this divided by x plus 2. Yeah, 5x cubed plus 6x plus 8 divided by x plus 2.
Wow, that 2 looks like a
Which one? The degree?
cube. Yeah, yeah. It's short of it.
This is third degree. It did.
I heard it too. What the hell?
No, it's third.
No, I'm telling you, if you go down to her class right now, she has pizza. I can smell it.
Are we actually?
I'm dead ass. I smell it. I'm like
I can't smell
everything.
it. Wait.
I'm willing to bet money Davies has pizza in her room.
Author's ADHD. If you were to focus on your math, like what you
I'm
focus
so serious. I smell
We
it.
would have 100 in the book.
I was doing it.
Are we just what? Is it just not the same thing we've just been doing?
Yeah, I need you to do standard division.
Oh, that's why.
That's why it's hard.
I want you to try standard division this time.
Did you forget the negative? I forgot the zero. Oh. No, you're just.
Wait, how do you mean?
Everybody hates me.
Well, where's the numbers you got?
You know what I did?
Oh, you just use that. Oh, fuck.
X squared.
It's a 5x to a third, not square.
Oh yeah. Okay. Sure.
Wait, what?
Hey, wait.
5x squared. Wait, did anyone get? Wait, Mr. The last box is the remainder.
Yeah.
There's always a remainder.
No, they can have 0.
Okay, so if it's 0.
Actually, we want to get to 0 on some other situation. In this case, we are not 0.
Wait, this is so much easier.
It's a lot easier, yes.
So I'm gonna multiply.
Wait.
Wait, pull down. Wait, why pull down 5?
You need to write down this thing. Need to change sign first. It's a +2. You need to change the sign. So look at the first step. It says change the sign of the divisor and put it in the corner.
So I just erased it.
What's 26 times?
What's the second step? I didn't write down.
Write down the polynomial. So it says write down the coefficient of the polynomial. So this is the polynomial. This 1, 4, 5, and 5. But including the placeholder though. You have to hold something in place.
It should be 8 minus 4. I'm tired.
A placeholder is right between the 5 and 6 because you see the extra third degree when the extra first degree. So you skip the x second degrees. Alright. Do you realize that there's a placeholder? So there's a 5. And there's a 0. Why is 0? Because the x second degrees. And there's 6 and there's 8. And you're gonna drop the 5 to the -10. You multiply it and add, so that's a -10 times -2 is gonna be 20. It's 26. And 26, -52, and this is 44. -44, right? Okay, so how do I write the answer? You're gonna go from third degree, go down to second degree. So it'll be 5x squared minus 10x plus 26 minus 44 over x plus 2. This is okay?
No, what's 5 0 here? I still don't know.
Because it went from third degree to the first degree. So in the middle, it must be with 0x to the square.
Right. That's what I'm thinking.
Is that okay? Now we're gonna go to the next part. Next part is talk about what's the remainder theorem. The remainder theorem is says if the polynomial f of x is divided by x minus c, then the remainder is f of c. So the remainder is an evaluation of if you were to plug in c. And this is interesting. This is very, very interesting. Because what it's saying is this. If f of x is equal to 5x cubed plus 6x plus 8. So for the previous example, this means if I were to plug in f to the negative 2, if f to the positive 2, 2, if I were to plug in 2,
What is this? The remainder?
The remainder is f.
now it would have said f f of minus 2, sorry, if f negative 2. Guess what? If I were to plug in negative 2 in this case, which is we used previous questions, right? If we were to plug in negative 2 in this case, you would get negative 44, believe it or not. And if you don't believe me, that's fine. Plug in negative 2 into the function. And this is on SAT, by the way. This idea is on SAT, by the way. So it's going to be 4 times negative 2 to the third plus 6 times negative 2 plus 8. What's a negative 2 to the third power? Negative 8. So negative 8 times 5. And then negative 12 plus 8. So that's going to be negative 40, negative 12 plus 8. So do you see this and this are the same? So in a way, I can use for evaluation. If I evaluate something, there is a way is you plug in negative 2. Or you just do standard division. So for example, if I have understand this idea, can you tell me f of x equal to x to the cube minus 4x squared plus 5x plus 3? And I say, hey, can you evaluate f of 2?
Wait, do you just want to plug in?
No, I don't want you to plug in. I want you to use standard division to find out what the f of 2 is.
So you just do standard division for the remainder. Oh. Wait, so x is.
So just plug it in. So just x is 2 now.
No, I don't want you to plug in 2. I want you to use synthetic division to find out it's 2.
Oh, you want to make. Oh.
So with synthetic division, you don't need to change the sign anymore. 5x, yeah. So you check just 2 like this. Just plug in 2 like this. Just use synthetic division. Use 2. If they wanted 2, just plug in 2 here. You don't have to switch sign anymore. If you want an evaluation, just use that 2 there and just do 1, negative 4, negative 5, and 3. And so actually it's a little bit faster. 1 times 2 is 2. Which one's positive 5? Oh, this one's positive 5. Okay. So this one's negative 2. Negative 10 times 2 is what? Negative 4, right? Negative 9. And that is a negative 18. This is negative 15. Oh, did it? Why people told me to change it? So this one's 1. Is that better? And 1 times 2 is 5.
Wait, how is
Now, if you don't believe me, experiment this. Let's experiment this. F2. 2 to the third minus 4 times 2 squared plus 5 times 2 plus 3. That's equal to 8 minus 16 plus 10 plus 3 is equal to negative 8 plus 10 plus 3 is equal to 2 plus 3 is equal to 5. Same answer as this. So there's 2 ways to evaluate this. You don't change the sign if I want an evaluation. So don't change sign if you evaluate. If you evaluate number. So you don't change sign. Just do 2 and standard division. Okay, I will give you a hard one. See if you guys can do it. Are you guys good at fraction? Imagine you want to ask you to evaluate for this, right? Do you see any placeholder on this one? There's no placeholder. Good. So I say, hey, can you evaluate negative 2/3? Imagine that you want to plug in negative 2/3 in this equation. You think how painful that's going to go through. But try with a synthetic. You might find it a lot easier.
easier?
A lot easier. Believe it or not, you just have to know how to multiply fraction. Which is most of you guys should be able to multiply fraction. Supposedly.
Yeah, -2/3 or
Negative 2/3.
It's 3.
Yeah. Hold on. Let me rewrite this. 3. Any number you need to make sure. 6, 10, 5, 1, 1. Anybody got an answer? Okay, is a matchup the answer? Imagine you were to plug in negative 2/3 on this equation. You think about how painful that will be. But this is actually much better if you really think about it. Did you do it first step? What do you do first step? You didn't even do it. Just give up.
No, I didn't. I didn't. No, 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 no.
Yeah,
It goes to 2, 3, 2.
yeah. Well, yeah. So then you first
No, no, no.
you got that. So then you multiply 6. And then you got that.
We is me.
this is last game. I didn't know they made this one.
Come on.
Can you go up? I already
Did you ever watch Ed?
Ah!
That Fortnite guy? No.
It's not short, you average. Wait, are we supposed to put 1-1?
Peter, can you help him?
Yeah, we're supposed to put 1-1.
Harper, you got it?
Maybe like this year, I'm gonna get a better score.
What's been pretty cool though? Ben, didn't you get a better score than me on first? 75.
Yeah.
Of course, the first test was my worst test of the year. And then the third test, I got a 96, and the rest was
Mine was like, how many tests was it? I don't know, I got 88, 89, 90 something. Yeah, no, I got it.
we've taken 6
Jeez.
5 or 6.
No, calm down. Calm down.
Why the fuck is Leo winning?
Because I almost said the forbidden numbers.
What are you even gonna do? I feel like you can't drive.
No, up front.
Yeah, exactly. I know.
I drive every day.
I used to drive like every week, and now it's not I can't drive anymore. I don't drive anymore.
You're like the ultimate character type, bro.
I don't know, because I made a mistake while driving that they never see it.
I mean,
Literally,
this big.
it was a nine.
What you guys get for answer?
That didn't work out.
What?
Yeah, that didn't work out.
7 over 9?
I thought you wanted
One time, this huge coach track was like, I was on the highway and he was merging into me. He was trying, and a huge truck was merging into me. So you went after the.
Okay, is everything okay here?
Yeah.
So- So it makes evaluation a lot easier, and it's very, very important that we try to make the evaluation easier. Okay, so now with that knowing is what if this is a 0? Like what if that is a 0? Right? What if the remainder is 0? This is our goal. Our goal is to understand something, because if that's equal to 0, it makes itself it's a factor. I don't know if it makes sense. Okay, so this is what SAT will test you. This is how SAT will test you, okay? So we're gonna give you a situation that you have to do this. And then we says hey, I want you to factor this. So factor 2x cubed plus minus 3x squared minus 11x plus 6 is equal to 0. So we say, can you factor and solve for this? But I'm going to tell you, it says giving 3 is a 0. 3 is a 0. I'm going to tell you 3 is a 0. Okay, given that 3 is equal to 0. Now put in mind, if 3 is equal to 0, I can double check. See, we can double check by plug in, right? So it'll be 2, negative 3, negative 11, 6. And we say 3 is a 0. How do we know that? We plug in, we double check. 2. 2 times 3 is what? 6. This is 3. 3 times 3 is what? 9. Negative 2 times 3 is what? Is 0. So we are telling the truth. But remember, x equal to 3 is a 0. Nicholas, come back to me. If x equal to 3 is equal to 0, can I move this to the other side? To x minus 3 is a factor. So can I say it's x minus 3 times 2x squared plus 3x minus 2? Because we told you 3 is a 0, so x minus 3. But this is what the result is. If you times those two, it's going to give you this, technically. Because remember, this signs change. So now, can I factor more? Yeah, of course. This is going to be 2x squared minus 2, 3x, 2x and x, 2 and 1. This is a 4x and negative x. So it'll be 2x minus 1 times x plus 2 and then x minus 3. It turns out if I give you 3 is 0 and we say it's 0, that makes this becomes this. And that makes you can actually evaluate all the zeros now. Now you're gonna try it. 15x cubed plus 14x squared minus 3x minus 2. And we say negative 1 is a 0. And I want you to solve for all the 0. Yeah, it's 14. I want you to solve for all the 0. If I told you negative 1 is a 0, which is you can prove it by using the division. But whatever remainder there, whatever the polynomial over there after you divide, that is the rest of factor. So it's called factor theorem. Hopefully you guys understand this transition, this becomes a factor. If x equal to 3, then x minus 3 must be a factor. And this show up on SAT multiple times. It's one of the harder concepts. It's called advanced algebra, advanced mathematics. Solve for all zeros, which is solve for all the x-intercepts. Because you zone out for like a few seconds. Negative 1 0 is part of the question. If I told you, I give it to you, negative 1 is 0, I want you to solve for the rest of the 0. So obviously there's a 3 0, right? Because fundamental theorem of algebra says there was a 3, this means 3 zeros. Well, if you give it 1, you can find the other 2. Because the other one must be factorable. And just factor the rest. Devin, you done? Okay. That was fast. All right, I'm gonna go over really quickly. They say negative 1 is 0, so I put it in the corner. Arthur, pay attention because I'm just trying to help you. Negative 1 is 0, so I'm gonna put negative 1 over there. This is a 15, 14, negative 3, and negative 2. 15, negative 15 is negative 1. Negative 1 times negative 1 is 1. That's negative 2. Negative 2 times negative 1 is 2. 0. So yes, it's 0. So that means this x equal to negative 1 is part of 0. So you can move it, become the factor. So it'll be x plus 1. So x plus 1 times what equal to this? X times this. 15. And all we gotta do is factor the rest.
I'm doing. Oh, that's oh, is that what you got?
Ready-made make the most like obscure
Stick said that I don't read Roger, this is the best anal people. You guys know what?
Okay, bye.
Well, it's gonna happen. It's gonna happen.
I mean, what the hell?
Not-
Not this
I
kid
wanna
just
raise my
interjected
grade
and
from
you heard
class.
like the wrong side of the
And it's like, yeah,
You
hopefully
can.
it'll happen.
You want to help Arthur?
Actually, no, and you're live. I'm gonna go to debate, and then if I come back and I know you still here,